Okay. Guys, are you okay from that stage? Yes. Full comfortable. Ah, okay. Tagala will discuss this. First one, see, bond angle of 109.28 is found in. Under that, write like this. Under number 1. Bond angle 109 degrees is found in. So this is found in sp3 hybridization with a tetrahedral shape. With a tetrahedral shape. With a tetrahedral shape. With a tetrahedral shape. Ammonia is pyramidal. H2O angular. CH3 plus. Okay, CH3 plus is trigonal planar. CH3 plus is trigonal planar. NH4 plus is tetrahedral. CH3 plus is trigonal planar. CH3 plus is trigonal planar. This CH3 plus. And NH4 plus is tetrahedral. Right? NH4 plus is tetrahedral. So the answer is NH4 plus. Correct now, raise your hand. Okay. Hybridization of the underlying atom. You have write like that, and whatever the explanation I'm telling, write like that. Hybridization of the underlying atom change in which of the following transition? Hybridization of the underlying atom. Hybridization of the underlying atom means number 2. Number 2 is like this. Here they have given aluminium hydride for AlH4 minus. Aluminium hydride is this AlH3. AlH4 minus mean this AlH4 minus. AlH3 is this without this. This one hybridization is here. When is AlH3, it is sp2. AlH4 minus mean it forms a complex ion. It forms a complex ion with hydrogen. It forms a complex ion AlH4 minus. Right? This is the complex ion of AlH4 minus. In this, they will form. Okay, here aluminium's hybridization is sp3. Then H2O changes to H3O plus. The oxygen hybridization. Okay, oxygen in H2O, the hybridization of oxygen is sp3. Oxygen's hybridization in water molecule is sp3. In H3O plus means there is one more H here. There is only H3O plus. H3O plus also sp3, so no change. Ammonia and ammonium plus. Ammonia also sp3, ammonium plus also sp3. Oh, in all cases is not wrong, so answer is aluminium hydride changes to AlH4 minus. That's the answer. Who got correct answer? Question is hybridization of the unlight atom changes in which of the following transition? Hey, hybridization, the question is hybridization. They have asked what is hybridization of the atom changes. Okay. Number 3. The number of lone pairs on xenon in XeF2, XeF4 and XeF6 respectively. Lone pairs on xenon. How many lone pairs in xenon in XeF2? Okay. This xenon number 3. You have to draw tackle XeF2, XeF4, XeF6. XeF2, XeF2. How many lone pairs are there? 3 lone pairs in XeF2. This is XeF2. 3 lone pairs. F4, XCF4, you got two lone pairs. Okay. This is a linear shape, that is square planar shape. And XCF6 is octahedral shape. XCF6 for fluorine will come like this. Okay, this is tetrahedral. So lone pairs 3, 2, 0. 3, 2, 0. මෙතන තව එකක් ඉන්නවා. XCF6. XCF6 එක එක්කෙනෙක් ඉන්න ඕනේ. 1 2 3 4 5 6 තව එක්කෙනෙක් ඉන්න ඕනේ. ඉතින් මේකට අපි ෂේප් එකක් නෑ අපිට ඔකට කියන්න. right XCF6. So 3 to 1 කියලා තමයි යන්නේ. But in our level syllabus මේ ෂේප් එක නෑ. Right? But anyhow you can just tell the lone pairs. 3 to 1. 3 to 1 go. A square planar complex is formed by hybridization of following atomic. Square planar complex mean square planar should form by like this, no? Square planar, there should be two unpaired electrons. So what should be the hybridization of this? Some atom is like this, mean this is the square planar shape, no? sp3d sp3d2. Square planar shape is sp3d2. So one is 3p's and 2d's. So what देगा? Answers? Answer is D නේ. මොකක්ද ඔයගොල්ලෝ ගත්තේ? D නේ? Okay. D. You have to tell, you have to write under that square planar complex hybridization is sp3d2. What do you mean by px, py, pz? What do you mean by px, py, pz? What is px? What is py? What is pz? Orientations. If there are 3 orbitals, now you have learned in p orbital there are 3 p orbitals like this. No? 1, 2, 3. How these 3 things are there? This is only px. This is py. This is pz. Px is in the x-axis direction, like this. In x-axis direction, px. In the y-axis direction, py. Inside the board, pz. Inside the board, pz. One minute. Hello. Right. This is px mean the orbital in the x-axis like this. In the x-axis like this. This is px. Py mean it's in the y-axis direction. Pz mean I can't draw the pz. I can show you. I can take a thing like I can. Then that is pz. It is inside like this. Okay, can understand? So these are 3 axes. So understand. You had the proper knowledge like this. Px, py, pz orbital orientation. 26 people. 26 people. They are smart people. 27 people. It's like this. These 3 orbitals are perpendicular to each other. Got the point? They are like this. Are you guys clear? Right. So that's why when you are doing questions, you will your knowledge will be thorough. Because these people would have done more than 1,000 questions in these things. Right. Now the next one is, which of the following hydrogen bonds is the strongest? Strongest hydrogen bond, no kata, no sina. The strongest hydrogen bonds are formed by, who is that? From Fon. So F bonds only, highly powerful hydrogen bonds. Why are we telling like that? Because that's a more electronegative element. Then under that you can write F is more electronegative. Therefore, the hydrogen bondings of the HF hydrogen bonding is the powerful hydrogen bond on Earth. But aren't you writing anything? Oh, very smart. Okay. So HF bond is the powerful hydrogen bond out of all. HF is the powerful HF. Okay, powerful. But HF is weak acid. HF powerful bond but weak acid. Huh? Yeah, you can show that, but in exam they don't expect that. They expect to tell. If you tell like this, that is sufficient. Fluorine is the most electronegative element, therefore HF bond is the highest hydrogen bond. That is enough, right? But HF, although HF is the strongest hydrogen bond, though HF is the weakest acid in the halide family. From all the halides, all the hydrogen halides, who the hell are they? Hydrogen halides, no? You know halide family. You don't know halide family. How sad. Okay, ask your seniors. They will tell beautifully. What is halide family, Puta? Yeah, FClBr. Group 17 people only known as halide family. Halogens. Group 17 is known as halogens. Group 16 people name Taggala people forget. Very good. But calogens. Calogens name. Chalcogens. Group 16 people family. They have family name. Inheritance. Family chalcogen family. Group 17 people. Halogen family. We have name like that. Either 17 people's anions are known as halide anion, negative ions. Now, if you take fluorine, it's a halogen. F, it's a halogen. If you take F minus, we call that as a halide. That's the difference between a halogen and a halide. The people who are in halogen people's anions are halides. So we call in hydrogen halides mean puta HF, HCl, HBr, HI. HF, HCl, HBr, HI. Out of this, if I ask which one is having the hydrogen bond, only HF can form hydrogen bond. HF special ability. Other people can't, only HF can. What is that? Forming hydrogen bonds, right? HF mean his name is HF, not your name. Abdurrahman's name we call HF Abdurrahman. HF Abdurrahman. That's why these people are laughing at him. But HF means powerful. Yeah, same enemy. Most powerful hydrogen bond on earth is HF. Because they are powerful, you can't break them. That's why it became weak acid. You can't break HF. Very powerful. Right? Understood? Right. So HF is very nice. Don't forget HF. We also have HF. Now, out of this, now you have to select HF is very powerful. Even write these extra points. HF, HCl, HBr, HI. HF is the weakest acid. HI is the strongest acid. Why HI is the strongest acid? Because HI is having the weakest bond. HI bond is weak, therefore HI is the strongest acid. What is acidity mean? The ability to release H plus ions. Then who can release more H plus ions? The weakest bond can release more H plus ions. Guys, what I'm telling is it going to your head? Am I fast? Right. Okay. Again, HI is weak, therefore they can release more H plus. They can easily release H plus, therefore they are strong acid, very strong acid. HF is bond is strong, therefore very hard to break H, therefore that is weak acid. Right. That's it. Line number 5, 5, 6, 6. Which one of the following pairs of species have the same bond order? On the bond order, I'll teach bond order. Bond order. This bond order. These people know bond order. Bond order mean. Bond order mean. You remember number of bonds around the central atom divided by their resonance structures. For an example, now take Cn minus. If you draw Cn minus, when you make a Cn minus. Okay, this Cn minus. You can draw Cn minus. Carbon is 4, nitrogen is 3, 7 minus 1. You can have maximum 3 bonds. You can carbon 4, nitrogen 3 with minus 1, 4, 3, 7, 1, 6 means 6 divided by 2 means you can have 3 bonds for Cn minus. So if you want to make a minus carbon only, get the minus charge here. You don't have any other way to do it. Cn minus is the way. Right? This Cn minus. Right? Okay. Now, other one, NO plus. NO plus. What is NO plus? We'll draw the structures. NO plus how to do? nitrogen is 3, oxygen is 2. With the plus charge, 3, 2, 5, 6 divided by 3, divided by 2, answer is 3. So NO also, NO plus, ne? Is it NO plus? You get 3 bonds. Who get the plus charge then? Oxygen. කරන්න දෙයක් නැහැ. මෝට තමයි plus එකේ. Right? Then other one, Cn minus and Cn plus. Cn plus mean here minus 1, C4N3 plus 1. 4, 3, 7 and 1, 8. 8 divided by 2, answer is 4. 8 divided by 2, what is the answer? 8 divided by 2, answer is 4. So Cn plus mean, Cn plus, you can make up to 4 bonds. Okay, but between cyanide and nitrogen, carbon and nitrogen, what is the maximum number of bond you can do? If it a plus charge, like 4 bonds we can draw for Cn plus, right? එතකොට මේ carbon nitrogen, because between two atoms, what is the maximum number of bonds we can draw? That is 3. Sorry, that we can draw the whole bond. Instead, what we can do, we can take one electron. I have take one electron and I wrote first like this. Okay. මෙතන plus දැම්මොත් මෙතන 5 electrons එනවනේ. I can do that also. Then I have to put the plus on nitrogen. And I have to send one electron. Cn plus එක මේව තමයි we can draw here. Okay. Cn plus. Cn plus. This is Cn minus. And Cn plus එක I can send for the carbon. I'm sorry. Carbon එකේ there is however there is a electron. And the electron I can send and I can form the Cn plus here. Okay, but here you get other one, what? O2 minus. O2 minus, no? O2 minus. O2 minus mean O2 mean 4. O2 mean 4. Minus 1 mean 3. Then 2 bonds. O2 minus, I think I have to send one electron like this. Likewise, only I have to draw the O2 minus. Okay. O2 minus. However, I can't draw this now. The mega, these things you can't draw with the double bond. If you put a double bond, what will happen? The number of electrons around oxygen will increase. Okay. You can't increase the number of electrons, no, however. Okay. Then 1, 2. These are some exceptional cases. මේ එක bond එකක්වත් everything won't come to you. These are some exceptional case you get. Okay. Then meaning I have to keep it a minus. I have to send 2 plus to that side. Okay. Then just take this O2 minus away. O2 minus එක ඔයගලන්ට එන්න, right? This you have to adjust with minus plus charges to get the plus. Oh, sorry, O2 minus. Then one side you have to put 2 minus and one side you have to put a plus charge. ඒවා exceptional things. දැන් ඒක ඔයගලන්ට ඕනේ. Right? So from these things, then other one is NO plus Cn minus. Okay, now from this, you see which one you can go as the bond order, right? The best bond order, you can go for this. Okay, for the Cn minus and NO plus. right? Okay. Now in this you have to go. Okay. Then for this one, Cn minus and NO plus, you can see the bond order. Can we draw another resonance structure for Cn minus by putting minus to nitrogen? Can I put another one by putting minus to nitrogen? Can I draw another one for Cn minus? So can we draw another one for NO plus? Can't we draw another one for NO plus? NO plus with nitrogen and oxygen. NO plus like this. And fifth one, this is unstable, right? Unstable, unstable. It's not filled the octet, right? Therefore, Cn minus and the Cn plus, they are bond order only same because these people can make resonance structures NO plus. Therefore, resonance structures nisa their bond order decrease because number of bonds changes, right? Therefore, you have to go for Cn minus and the Cn plus bond order. Okay, Cn minus and Cn plus. Okay, right. Both are bond order 3 kila you can write. Cn minus and Cn plus. For Cn minus, can you draw another one? You can't. That is for Cn minus. Okay, for Cn minus. If you put two bond like this, then I mean without this, you can select the number of bonds using this. But Cn minus mean, for an example, we'll say 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. Then here 1, 2, 3, 4, 5, 6 you can put a minus charge. Then 2, 4, 6, 8. Still, this is also unstable. You can draw like this, Cn minus and NO plus. But Cn plus we'll see whether we can draw like that. If the double bond, these are unstable structures, right? කරන්න දෙයක් නැහැ. මේ පොඩ්ඩක් කවුල් වෙන එකක්. චුට්ටක් it has gone apart from your this one. But still, we touch this question. ඉවර කරලා දාමු ඒක. Then Cn plus mean, in the Cn plus part, if you put a double bond here, okay, if you put a double bond here, you can whatever the number of bonds here, ekama dala no need to draw. When you're drawing unstable structures, you can reduce the number of bonds when you're doing unstable structures. Okay. Now, the method of 4 kila between carbon and nitrogen, Cn plus, you can't put 4 bonds in both between carbon and nitrogen. Okay, we can put between 4 bonds. Okay. Then between Cn in, if you want to form plus 1, we'll say 1, 2, 3, 4. Cn plus 1, 2, 3. And I can put a plus here. 1, 2, 3, 4. And I can put a plus here. Then method we can go for bond order. Okay. Now, therefore, දැනට පොඩ්ඩක් කොහොම තියන්න 6 question, right? ඒ චුට්ටක් කොහොම තියන්න මේ ඒක within අපේ A level syllabus ද කියලා I have to double check, right? Because it was නැත්තම් මේක order upset වෙයි නිසා I will tell this part. නෑ ලන්ඩන් නෙමෙයි. ඒ කියන්නේ chemistry තමයි ඔක්කොම, but within A level ද කියලා I have to පොඩ්ඩක් double check. මම bond order කියලා දැම්ම නිසා දැම්ම ඕක, right? මේක එච්චර deeply value නැහැ, but එතන තියෙන molecules ටික පොඩ්ඩක් චුට්ටක් it's more than your A level level. හරි ඒක ඒ නිසා පොඩ්ඩක් කොහොම තියන්න එතන ඒක කොහොම තියන්නකො 6 question එක. හරි. We'll come for the seventh one. හරි. Sixth one එක I will confirm. Seventh one එකට එන්න. The halide having the highest melting point. The halide having highest melting point. Which halide will have the highest melting point? Sodium fluoride. Reason? Sodium fluoride. Reason? Tell. Because all the cations are same. What is different? Anion. Fluorine, chlorine, bromine, iodine. Here fluorine, chlorine, bromine, iodine, all are what? What group? Halides. All are halides. Fluorine, chlorine, bromine, iodine. Out of these halides, who is small one? Fluorine is the smallest one. Fluorine is the smallest one. Me. If the fluorine is the smallest one, then fluoride. The polarizability. Can you remember polarizability something? Polarizability high in who? Hmm? Polarizability for who? For whom we are speaking? Cations or anions? Anions. Polarizability we are speaking for anions. Polarizability is high in who? Polarizability high in study rich girl. Polarizability anions mean girls no study rich girl only. Plus name minus. Study rich girl having the highest polarizability. Study rich girl. Highest polarizability. So when the polarizability is increased, what will happen to the stability? Stability reduces. Stability reduces. Polarizability increases means stability reduces. If the stability reduces, what can you say? Stability reduces means their melting point reduces. Boiling point reduces. Edakote stability, you have to tell fluorine's polarizability is less. Right, like this. Fluorine's polarizability is less. Fluorine's polarizability is less. Therefore, fluorine's polarizability is less. Therefore, uh, its stability is more. Its stability is more. Its stability is more. Its stability is more. Therefore, its melting point and boiling points are high. Therefore, its melting point and boiling point is high. Therefore, its boiling point and melting points are high. Okay. Number 9, the charge over size ratio of a certain determines its polarizing power. Question number 9, which one of the following sequences represent the increasing order of the polarizing power of the cationic species K plus Ca2 plus Mg2 plus and Be2 plus? Okay. Under polarizing power, write like this. Polarizing power high is, polarizing power we are speaking for cations. I told quarter rich boy. Quarter rich boy, polarizing power is high. Whose polarizing power is high? Quarter rich boy. Short rich boys, polarizing power is high. Then who is short rich in this? Beryllium is there, potassium is there, calcium is there, magnesium is there. Who is short and who is rich? Beryllium. How do beryllium ne small? Beryllium is small. Why? Beryllium, magnesium, calcium. It goes like that. So beryllium is the smallest one. So small and rich. Beryllium is small and rich. Why? Beryllium is 2 plus. So whose polarizing power should be the highest? Beryllium 2 plus. In which answer we have beryllium 2 plus in the first place? B. The answer is B. Who selected B? Small, not small, high charge cation has the highest polarizability. Therefore, beryllium 2 plus polarizability is high. Therefore, beryllium 2 plus polarizability is high. Okay. Then the next one. Then the next one, Putta. Which of the following is an electron division molecule? Electron division under that, right? Group 13 elements are known as electron division compounds. Most of the group 13 elements are known as electron division compound. Most of the group 13 elements are known as electron deficient compound. Therefore, boron is a group 13 element. Boron is a group 13 element. Therefore, uh, it is known as electron deficient compound. So answer is what? B2H6. Okay. But B2H6 you can write specially. In B2H6, they fill the octet. In B2H6, they fill the octet. In B2H6, they fill the octet. When it is as BH3, it is electron deficient. Okay. Right. Now, these things are fine. Now, you can see in which of the following molecules ions all the bonds are unequal. SF4, what is the shape of SF4? Huh? Tell me the shape. SF4 is what? Tell people SF4 shape. Why you are thinking so much? SF4 shape. Huh? What? SF4 what? CSO. SF4 is CSO, no? Right. Katya, when you see SF4, S mean 6 electrons, no? Sulfur. So SF4 means CSO. Like this. SF4. CSO up and down. SF4. SiF4 mean tetrahedral. SiF4 mean tetrahedral. Right? Because silicon is 14 group. XeF4 square planar. XeF4 square planar. XeF4 square planar. Another one is BF4 minus. BF4 minus is this. BF4 minus. What is this? Tetrahedral. So which one is the answer? What is the answer now? Answer is A. Yes. Why? Because in this all the bond angles are same. It's 109.5. This one 90 degrees. This one 109.5. Here bond angle is different. This side it is 180. This side it's change. Okay. So bond angles are different in SF4. Therefore, all the bonds are not same. All the bonds are not equal. Bond angles are different. Question number 12. Among the following pairs, the one on which the two species are not isostructural. Isostructural mean what? Same structure. SiFO, SFO already we have given here. SiFO, Tatakal write the shapes. SiFO is what? In front of these things, write the shapes. SiFO, tetrahedral, SFO, CSO. So not same. IO3 minus linear, XeO3. IO3 minus linear, sorry. IO3 minus is what? IO3 minus pyramidal. IO3 minus pyramidal. IO3 minus is pyramidal. XeO3, that also pyramidal. Same. The first question are not isostructural. The first one answer. But IO3 minus pyramidal, XeO3 pyramidal. You know no IO3 minus pyramidal. You have problem in that. So maybe are you writing or only I am writing on the board? With this, you have to understand. You have to improve. Iodine is group 17, so these things you can connect with the Lewis structure with the equivalent to their what this one valencies. So this IO3 minus XeO3 means xenon is group 18, XeO3 is this. Okay. Both are pyramidal. BH4 minus NH4 plus already I drew. Eva tetrahedral. PF6 minus SF6 both are octahedral. Okay. Both are octahedral. Therefore, the answer is A. Hybridization of 1 and 2 carbon atom. CH2 here. 1 and 2 carbon atom. This is 1. Okay. This carbon is sp2. This carbon is sp. So first one is sp2, second one is sp. So answer is C. Can understand Buddha? This sp2 kilo can understand. This one is sp kilo can understand. Seriously, I'm asking. Okay. Which of the following molecules contains one lone pair of electrons on the central atom? That is NH3. Those are easy questions. NH3. The molecule having highest bond energy. Is the highest bond energy. It's easy. Which one? Which bond energy is highest? Whose bond energy is highest? NN bond, SEC bond, FF bond, O bond. Who is having a triple bond here? Mostly exists a triple bond. Who is mostly exists a triple bond? Nitrogen. So whose bond energy is high? Nitrogen. Okay, nitrogen's bond energy is high. From fluorine, chlorine, bromine, iodine, whose bond energy is high? This is a very nice question. FF, Cl, Cl, Br, Br, II. Whose bond energy is high? Make I think 2027 people can't answer. It's a very extraordinary question. Always they can ask in exam, special one. Whose bond energy is high in this? If you tell in order, who comes first? Who comes second? Who comes third? Who comes fourth? In bond energy, Cl2 bond energy is more than bromine. Bromine bond energy is more than fluorine. Fluorine bond energy is more than iodine. Fluorine come to third place. I have told you this one nearly 3-4 times in 26 classes. Right? I have told you because fluorine molecule is small. Because when fluorine and fluorine small molecules, because of those, there is a repulsion between the nucleus. Therefore, their bond energy reduces. Therefore, it comes to the third place. Other thing goes in order. Chlorine, bromine goes in order. Fluorine comes to third place because fluorine is a small molecule. Therefore, it has nuclear repulsion. It has nuclear repulsion. It has nuclear repulsion. That's why it has low. Okay. 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 That's right. Then okay. Then we'll wind up. Okay.